Hey class, it's Mr. Chang, and I've got the next lesson here for you. We're talking about exponent laws, and just like in trig, I think for a lot of you this is going to be review because you learned this before, and that really should be the way I'm looking at it and the way you should be looking at it because a lot of this stuff should really ring a bell. We are going to talk about the most common exponent laws, and then we're going to talk about some new stuff like zero and negative exponent laws, and then also fractional exponent laws. A bunch of different things to try to cover. So let's get at it. Okay, our goal today is to review and practice the exponent laws from grade 10. First thing I want to talk about is a power. You see here, a power here, or exponent, it indicates how many times a base, okay, is repeatedly multiplied. So if you look over here, imagine like a times a times a times a. What this is actually talking about is a base of a, okay, that's repeatedly multiplied, in this case, 4 times. Let me tune that up there. Multiplied 4 times. And so a to the exponent 4 means a times a times a times a. It doesn't mean 4 times a or a times 4, okay? It means a times a times a times a, which would give you a really large number really quick if, you know, a was a constant like 2, 3, and so forth. What about if I had like 5, right? 5 times 5 times 5, my base is 5, and my exponent is 3. So let me just take a moment and indicate that here. This is my exponent or power, right? And this is my base. Okay. Sometimes the entire term here is referred to as a power as well. Okay, just because there's going to be different points where somebody might refer to a4 as your power, but a to the power of 4 or a to the exponent of 4 is more commonly the way it's described. Okay, so one thing to know is that the exponent sits directly on the base. And so what is the base is the next question. You see, if you look over here, we have a negative base. Powers of negative bases, okay, powers of negative bases must be indicated with brackets. You see, here I have negative 2 to the exponent of 3. Isn't that negative 2 times negative 2 times negative 2? No. You see, this is actually negative 2 times 2 times 2. Okay, the 3 is only sitting on the 2. The negative is not directly attached to the negative 2. We make the difference a different indicator to try to understand the difference, because if you look at this one over here, this is negative 2 all cubed, but the power of a negative base, here powers of negative bases must be indicated with brackets. This is negative 2 times all of negative 2 times all of negative 2. Okay, in both cases, here you're going to get negative, and then 2 times 2 times 2 is 8, and here you're going to get also negative 8. But if this was 4, for instance, this would be negative 16. But if this was 4, this will become positive 16. Okay, something to be very aware of. Okay, so let's see if we can check out what goes on next. What I'm going to talk about are the rules of exponents or laws of exponents, right? And so if you look at this little chart here, I want to go through each one individually. The first one here I want to talk about is the multiplication rule. And that's when you have a base, okay, that's the same as another base, and they're being multiplied together. What you do is you look at the exponents, and the exponent here is x, and the exponent here is y, and you end up with leaving the base still as it is, right? You get x plus y. Okay, you just add the exponents. So what does that mean? Let's look at these two examples up top. Here in this first case, you're going to see 2 to the exponent 3 times 2 to the exponent 40. And you can actually punch this in the calculator and see what you get. However, if you understand that this is the multiplication rule, the reason is because you have the same base, which is 2, and they're multiplied together. All you have to do is add the exponents. Leave the base alone and add the exponent. So in this case, I'm going to leave the base alone, add the exponent. This is 3 plus 40, which you don't need to write, but I'm just going to show it, which gives me 43. 2 to the exponent of 43. And that's the answer. Okay? Or let me use a highlighter to indicate. There, done. What about the next one over here? This is 2a cubed times negative 3ab to the exponent of 4. All right. Is the 2 and the 3, is that the same base? No, but they both have an a, right? And they're all being multiplied together. There's a b over here. So what really happens? Let's deal with the sign first. This is a positive times a negative. That gives me a negative. 2 times 3 is 6. A3 and a, well, there's a 1 on this. Okay? If I don't write it, there's always a 1 on it. And in this case, a3 and a to the exponent 1, if I add the exponents, I get a to the exponent 4. Okay? Then I also have b to the exponent 4. Just tweak that up there. Okay? And done. That is a multiplication rule. Let's talk about the division rule next. Okay? With the division rule, what we're looking for is, use a different highlighter. With the division rule, what we have is a base to an exponent divided by the same base and another exponent, and you end up rewriting the base and just simply subtracting the exponents. Okay, in that order. So let's see that happening too. Division rule. We've got a couple examples right here. Okay, so this one's pretty quick. 3 is our common base. You can see that the operator happening in between is dividing, right? So we should be thinking division rule, or the quotient rule, some people would say. And so 3 is our base. We just simply rewrite it. And let's divide the exponents in that order, or the powers in that order. It's 7 and the 3. And you end up with 3 to the exponent, 7 subtract 3, which is 4. Okay? If you wanted to actually work this out, 3 times 3 is 9, times another 3 is 27, times another 3 gives you 81. Okay? That's the evaluated form. And this is the exponential form right here. Both of these examples are good. However, if I'm testing you on exponent rules and you're demonstrating the exponent rules, really I'm looking for this answer right here. Okay? Unless I say evaluate it, you still have to show all these steps and then give me the 81. Otherwise, it just looks like you did it on the calculator. All right. I mean, calculators are good for checking, but it's not actually good for just doing it, because if you don't understand the rules, you just do it on the calculator. I mean, you'll get the answers, but you won't get any of the part marks, which is not going to be helpful at all. Let's check out what happens next. Division rule, right, or quotient rule. You can tell again because this is 4 to the 5, a7, b6, all divided by. That's what the dividing means, right? 4, 3, a3, b. So let's deal with it one by one. First, sign-wise, it's positive, right? Positive divided by positive is positive. 4 to the exponent 5, you could work it out, and 4 to the exponent 3, you could work that out too. But if you recognize that it's the same base of 4, then let's just subtract the exponents. 5 and 3 gives me 2. All right, in that order, the top subtract the bottom. Here we got a, top subtract bottom, with the exponents is 7 subtract 3 gives me 4. And then b6 and b to the 1, right, is b to the 5. That's it. We are technically done. However, we have a simple coefficient here to an exponent 2, so we can work that out. 4 squared is 16, then a4 and b5. Good? All right. So that is the division rule. Let's talk about some of the other ones. Next one up is the power of a power rule. Okay, here I got a power. It's a base to an exponent, and I put it in brackets to another exponent. That actually means you could just rewrite the base and multiply the exponents. So let's see that in action. That actually happens with these two cases right here. So what's going on? Negative 3, a4, b3. Okay? what I'm going to do is I'm going to multiply the exponents. But you have to recognize that this negative 3 is a coefficient with an exponent 1. This b is also to exponent 1. You see, what really needs to occur here, if I write equals, I actually have negative 3 to the exponent 3, okay, because that's in brackets. And then a4, a to the exponent 4 to the exponent 3. And then I also have b, right? There was a 1 there, to the exponent 1 to the exponent 3. You got to multiply in this case, because this 3 needs to apply, this cube needs to be applied to all 3 of those parts there. So in this case, this gives me negative 3 times negative 3 times negative 3, or negative 3 cubed. And then here I got a4 and 3. Actually, I can multiply these two. That gives me a12. Okay, bracket gone. And here, 1 times 3, this is b3. So what about here? This is negative 3 times negative 3 times negative 3. Okay, so negative times negative is a positive times negative is a negative. I end up with negative 27. Okay, negative 3 times negative 3 is positive 9. 9 times negative 3 is negative 27. A12, B3. Done. Let's see it in action again over here. Here we've got a negative on the outside, 2 squared, A9, B7, all cubed, right? So what happens next? Well, this negative stays. Let's look inside the bracket. Is there anything to do? Actually, 2 squared, we should do that first, okay? And then A9, B7. Nothing left to simplify. Let's take it a next step in. Should we send that negative in, or should we do the exponent 3? Well, if you think about it, BEDMAS indicates that you should do brackets first, and that's why I did the 2 squared, because that was a part of doing something inside the brackets. There's nothing to do left in the brackets. My next job is to handle exponents, and then division and multiplying, and that's what the negative is here. The negative is a negative 1 into the brackets. That's multiplied. So we got to do the exponents before we do the multiplying. So let's leave that on the outside. And let's talk about what happens here. This is 4 to the exponent 3. A to the exponent 9 times 3, which is 27, and b to the exponent 7 times 3, which is 21. Negative, right? 4 cubed is 64. A27, B21. And we're just going to send that negative in. 64, A27, B21 is my final answer. Okay, we're flying right along. And you know what? That's the thing. It's a review, so that should be a reasonable outcome here. So we just talked about the power of a power rule, okay, or the power of a product rule, because the product rule is essentially what I just did as well, okay, right? I distributed that exponent, for instance, in this case, right, this x needs to go to the a and the b, and that's this 3 going into here, here, and here, okay, and that would be an example of the product rule. I kind of killed 2 birds with 1 stone there. We got to talk about the last one. That's power of a fraction rule. Okay, so we've got negative 2 over 3. Here's a fraction, and to the exponent 3. And really what's going on, actually, if you look over here, is when you have a fraction and an exponent on the outside, that exponent needs to go to both of the terms. And it ends up like this. You see that? So in this case, really what's happening is this becomes negative 2. Actually, it's better to write it like this. Negative 2 cubed over 3 cubed, which gives me negative 2 times negative 2 times negative 2, which is negative 8, all over 3 times 3 times 3, which is 27. Okay. And one more. Let's bring it on home. Let's take this down like this. 3a squared over 4b cubed, all squared. Okay, let's look inside the bracket. Is there anything to do? In this case, no, there's nothing I can do, right? These are unlike terms. This is an a, this is a b, the 3 and the 4, they can't divide evenly, and the a's are not the same bases, or the b's are not the same bases, so we can't just subtract the exponents. We're done with what's inside the bracket. We got to handle what this exponent 2 is, and we have to apply it to all of these exponents that are all in here. Okay, so what really happens here is this becomes the 3 all squared. A squared squared. Okay, and then 4 gets squared, and then the b cubed gets squared. There's a bunch of squaring involved. Let's just do this. We should have a square jar. I apologize. All right, 9. A2 and 2, we're multiplying that. We get A4. All right, and then 4 squared is 16. And then B3 and 2 gives me B6. Done. Okay, so hey, I just went through all these different rules with you guys. Hopefully it was pretty clear and nobody got super confused. It should be a review and all that stuff. I've got some practice here on the IXL stuff. You go to level K section I and just go ahead and try all those things, but don't do I.4, okay? As long as you're seeing any of these rules like multiplication rule, division rule, power of a power, power of a product, power of a fraction rule, you can do it, okay? And then you also got these workbook pages for you to try too. Got it? Good luck. Fire me an email about anything you can't get, but it should be a review. And if you want, you can watch another lesson on YouTube on exponent laws. Somebody might do it better than me anyways. And that's that. I hope you guys are well, and stay tuned for the next lesson.